Hi everyone, so in this video, we're going to do some practice on balancing chemical equations. Now, when you're balancing a chemical equation, you need to realize that you cannot change the subscripts. So subscripts are again these little tiny numbers right here, and they basically tell you how many of that particular element is in that molecule. So if I'm looking at here, N2, it's saying that in nitrogen gas, I have 2 nitrogen atoms chemically combined. So that's what this means right here. And if I'm looking at O2, well, the same logic is applying. Is that in one molecule of oxygen gas, I have 2 oxygen atoms that are chemically combined here. And that in this skeleton equation, so when we're talking about a skeleton equation, we're talking about an unbalanced chemical equation. I see that if I take nitrogen gas and I react it with oxygen gas, I could make dinitrogen pentoxide, so N2O5. So that would be 2 nitrogens bounded to 1, 2, 3, 4, 5 oxygens. So the only thing that I could do when I'm balancing a chemical equation is changing my coefficients. So that means putting big numbers in front of my molecules so that my total atoms and the total respective elements on the reactant side equals the same amount on the product side. So just going to erase these things here. What I notice, if I'm looking at my count, is that I have 2 nitrogens on the reactant side, 2 nitrogens on the product side, okay? I have 2 oxygens on the reactant side and 5 oxygens on the product side. So the thing that is not balanced, I basically need more oxygen. Now, if I'm looking at my numbers here, I have an even number here and an odd number here. So I have to basically put a coefficient to balance them out. But when we need to remember that whenever you multiply an odd number by an even number, it automatically becomes even. So for something like this, I need to look at my lowest common multiple. So what number do I get when I multiply 2 and 5? I get 10. So that means I need to be dealing with 10 oxygens in total on both sides. So that means if I put a 2 in front of my dinitrogen pentoxide, that means I'm drawing another molecule that has 2 nitrogens, 1, 2, 3, 4, 5 oxygens. So I now have 10 total oxygens here. And now I have 4 nitrogens here. So I need to get both more oxygen and more nitrogen. So let's deal with the oxygen first. I have 10 oxygens here. Well, what number times 2 gives me 10? 5. So that means I'm having 5 oxygen molecules, and in each 1, 2, 3, 4, and in each oxygen molecule, I have 2 oxygen atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my oxygens are now balanced, but now I have to deal with my nitrogens. I see on my product side that I have 4 nitrogens. On my reactant side, I only have 2. So 2 times 2 is 4. And then I get now my 4 nitrogens. So what you're doing when you're balancing a chemical equation is that you're trying to get the same number of elements on the reactant side, same number of elements on the product side. And as you saw, I had to go forwards and backwards to balance them all out. So I hope this helps. What we're going to do is I'm going to do another one, but instead of drawing out the Dalton models, I'm going to do the counting method, is where I'm basically just going to be looking at the numbers and counts respectively. So let's go down to our next example. We have right here. So all I'm going to do before I count is I'm just going to draw a black line here to separate my reactants from my products. And now I'm just going to list the elements that I have. So I have magnesium, bromine, potassium, oxygen, and hydrogen. And I'm going to list them in the exact same order. The reason why is that when I'm looking across for balancing, it's much easier if they're all on the same horizontal line. So now what I'm going to do is I'm going to count the number of respective elements on my reactant side and my product side of my unbalanced chemical equation. So magnesium, I have 1. Bromine, I have 2, because next to the bromine, I have the subscript 2. So that means that I have 2 bromines bonded with magnesium in my molecule of magnesium bromide. I have 1 potassium, 1 oxygen, and 1 hydrogen. Now I do the same count on my product side. So on my product side, I have 1 potassium, I have 1 bromine, I have 1 magnesium, and now I see that I have oxygen and hydrogen contained in a bracket. So when you see something like that, to get your total amounts, you have to take the subscript of the element inside the bracket and multiply it by the subscript of the element outside the bracket. So I can see oxygen doesn't have a subscript, so that means it's default 1. So 1 times 2 gives me 2. Same thing with hydrogen, 1 times 2 gives me 2. So now if I'm looking at my counts, I can see that my bromine is not balanced. I have 2 bromines on my reactant side, 1 on my product side, and both my oxygen and hydrogens are not balanced. I have 1 on each on my reactant side, 2 in each on my product side. So the first thing I'm going to do, I'm going to balance my bromine. So I have 2 on my reactant side, 1 on my product side. Simply put a 2 here. So now this 2 is affecting everything because I'm basically saying I'm having 2 molecules of potassium bromide. So that means my total bromine is 2. My total potassiums are now 2. So I've noticed that I've dealt with my bromines. That's great. But now I see that my potassium is not balanced anymore. I have 2 potassiums on my product side, 1 on my reactant side. So if I look on my reactant side, I see that my potassium is bonded to oxygen and hydrogen, which, oh look, I also have 2 on my product side and 1 on my reactant side. So if I put a 2 right here, this now turns to a 2, this now turns to a 2, and this now turns to a 2. And when I go and check my counts, my magnesium, 1 on my reactant side, 1 on my product side, magnesium is balanced. Bromine, 2 on my reactant side, 2 on my product side, bromine's balanced. And if I looked at potassium, oxygen, and hydrogen, they're all now balanced. So what I have right here is now my balanced chemical reaction. All right, let's do one more for good luck. And let's choose something like this. So we're going to do this one. Carbons, I have 5. Hydrogens, I have 12. Oxygens, I have 2 on my reactant side. Carbons, I have 1. Hydrogens, I have 2. oxygens. Now this I have to be very careful for. This is also very common. I have oxygen suspended in two molecules on my product side. So that means I need to count the oxygen here and the oxygen there. So if I'm looking at the oxygen in water, I have one oxygen in water. If I'm looking at the oxygen and carbon dioxide, I have two oxygens and carbon dioxide. So I need to add them together. 1 + 2 gives me 3 total oxygens. So whenever I'm looking at something like this, so this reaction is basically a combustion reaction. I always form two products, water and carbon dioxide. So whenever you see something like this, you'll notice that the first element that I tend to balance is everything except oxygen and hydrogen. The reason why I do this is because once you balance all of your other elements, usually oxygen and hydrogen are balanced automatically, or it's just one extra step afterwards. So let's go ahead and balance our carbon first. I see that I have 5 carbons on my reactant side. I have 1 carbon on my product side. So I put a 5 right here. This now turns to a 5. And now my oxygen turns to 11 because 5 times 2 is 10 plus 1 is 11. Now the next thing that I'm going to balance is my hydrogen because again, oxygen is usually the last element that I want to balance. So I have 12 hydrogens on my reactant side. I have 2 on my product side. So that means I need to add more here. So what number times 2 gives me 12? 6. So now my hydrogens are now 12 and my oxygens are now 5 times 2 is 10. So I had 10 in the carbon dioxide. 6 times 1 is 6. So I have 6 in the water. So now I have a total of 16. So now what I have to do is I have to get more oxygens. And this is what I meant by balance everything and leave oxygen last. It tends to be the easy last step. So now what number times 2 gives me 16, and that is 8. 8 times 2 is 16. So I hope this helps. For the rest of them, there is going to be the detailed answer key, just not me answering all of the questions on video. But make sure that you don't just watch this video, but there's also a lot of other videos on balancing chemical equations on the class website. So have a great day.